Today we're going to see another example of the transformer element, and we are going to look at the equivalency between the block diagram method and the bond graph method by using this example. So you can see on the left hand side we have a piston that actually presses on a chamber in there, and then we have on the right hand side a pipe that has a different area. So this is a hydraulic transformer basically. So let's look in more detail. So I'm gonna disappear here. And how do we have the equations here of this? You see, you could define this as how do we actually define this? You could say that um, the the pressure is defined as the force divided by the area, right? So you could say that there is a relationship between this force here, and there's a relationship between the force over here. So you could say the force on one side, you could say that is a pressure times the area, and then you have, this is the side where we would have a, you could have that the force. How do you define pressure? Pressure is force divided by area, right? That's the definition of this. So on this side where you have this, you could say, okay, um, remember by Pascal's principle, you had the pressure will have to be the same, right? In distributed in all this. So in here you have that you have the mechanical side, and then you have the hydraulic side in here. So always you have that the force over here is gotta be equal to the area times the pressure, right? So on this side you have that the force is on the right hand side. The force would be on the right hand side, you say, let's call it F, so right is the area times the pressure here. And on this side we are considering, so this is the hydraulic side. Why don't we put it here, hydraulic side. And this is the mechanical side, yeah, where we have the variables in here are force and velocity, and in these other ones are pressure and volume flow rate. So it follows that the force times the velocity will have to be equal to the pressure times the volume flow rate. So in this case, the force here in on this side, it would be the, you will have that force on the left times A1 should be equal to the force on the right side, which would be the area times the pressure, area 2. Or you could write that F, call it F on this side of 1, yeah, F1 times CF1 times A2 okay. So this would be this equation that F1 is the pressure times A2 over A1. So this is one of the equations of the, but you see this also relates to the other variable. Like you have velocity in this case is Q is always area times the velocity, right? The velocity that multiplied by the ratio here is equal to Q. See, when you look at this, you have that F times the velocity equals to P times Q. This is power conservation. What we're gonna consider is that this element has two equations in here. Those two. In this particular case, what did I just do? Sorry, let me, I highlighted the wrong one. Let's get rid of this. And I will draw the other one over here, this one. So how do you write the block diagram of this? This is saying that which is the input, which is the output. This is in and this is out because this is the result. This is the output in this case, this is the input. So what are we gonna say? On the first one, you're going to say that this pressure coming in here multiplied by this constant A2 over A1 results in F1. That's this equation. But that is not the whole story. We need this one too. And the way that one is written is that the output is this one on this side, which is Q, and this other one is the input, and you have A2 over A1, and in here you have B. So this is the representation of these two equations. But if you come to a bond graph model where you have the TF element in here, the way you represent the same thing is that the input P, this is P and this is F in this case. And let me just change the colors here. This is Q on this side and this is V on this side. The way you do it is P is the input, F is the output, so it's like this, like that. And then it represents both of this. This is saying P multiplied by this A2 over A1 equals to F1. And that V multiplied by A2 over A1 is equal to Q. And so this is equivalent to this block diagram. These are equivalent. And that we see the transformer equivalency between the block diagram and the bond graph.